Hello everyone, welcome to our new course Electronic System Design using Proteus. In this course, we will learn how to design, simulate and analyze electronic circuits and systems using Proteus Design Suite. Before begin designing circuits, let us first understand what Proteus is. So Proteus is an electronic design automation software which is also called as EDA that is widely used for designing and simulating electronic circuits. In simple words, Proteus allows us to create and test electronic circuits virtually on a computer before implementing them on the actual hardware. For example, if you want to build a simple LED circuit, then we can select components such as LED, resistor and power supply in Proteus and create the complete circuit virtually. How to create this simple LED circuit using Proteus that we are going to learn after some videos. So we can then run the circuit in simulation mode and observe whether it is working correctly or not. Similarly, Proteus can be used to design and simulate diodes, BJTs, FETs, MOSFETs, operational amplifiers, timers, logic gates, flip-flops, counters, registers, microcontrollers, and many other analog and digital circuits. So now, let us discuss why do we need Proteus. When we build an electronic circuit using actual hardware, there is always a possibility of making wiring or component selection mistakes. A wrong connection or an incorrect component value can cause the circuit to malfunction. In some cases, an incorrect connection can even damage the electronic component. For example, if an appropriate current limiting resistor is not used or connected in with an LED, excessive current may flow through the circuit and which will damage your LED. So Proteus allows us to test the circuit virtually before building it physically. If there is an error in the circuit, we can easily identify and correct it without damaging any physical components. Therefore, Proteus is very useful for learning, experimentation, and circuit verification, testing, and troubleshooting. Now let us discuss what we can do in Proteus. So one of the basic application of Proteus is creating a schematic circuit diagram. Proteus always Proteus provides a large library of electronic components that can be used to design circuits. We can select and place components such as resistors, capacitors, inductors, diodes, transistors, ICs, switches, LEDs, displays, motors, sensors, and many other devices. These components can then be connected using wires to create the required circuit. Once the circuit is completed, we can run it using the simulation feature of the Proteus. During simulation, we can observe the behavior of different components and signals in the circuit. We can also measure the parameters such as voltage, current, power, etc. using virtual measuring instruments provided by the Proteus. Proteus also provides instruments such as voltmeter, ammeter, oscilloscopes, function generators, and logic analyzers, etc., which are very useful for circuit analysis. We can also use different types of graphs and plots to study the circuit characteristics of the waveforms. Now, another major use of the Proteus is Proteus can be used for microcontroller based systems. Another important feature of Proteus is its ability to simulate microcontroller based electronic systems. We can design and simulate systems based on platforms and microcontrollers such as Arduino, PIC, AVR, and others, depending on the available devices models and simulation support. We can Connect peripherals such as LEDs, LCDs, keypads, sensors, motors, displays, and communication modules to create complete embedded systems. This makes Proteus useful not only for basic electronic circuits but also for embedded systems and electronics system designs. Now let us discuss some of the advantages of learning Proteus. One of the biggest advantages of learning Proteus is that it allows us to understand electronic concepts through practical approach. Instead of only studying a circuit diagram theoretically, we can actually build the circuit on computer and observe its behavior. This helps us establishing a strong connection between theoretical concepts and practical implementation. Proteus is particularly useful for students because it allows them to perform and understand laboratory experiments in a virtual environment. It is also useful for engineers and circuit designers because circuits can be tested and verified before moving to the physical hardware implementation. We can easily change component values and observe how these changes affect the circuit's performance. This makes it easier to understand the relationship between component values, circuit parameters, and output behavior. Now let us learn what will we learn in this course. We will begin this course with the basic interface and working environment of Proteus. We will learn how to search for the components, select components, place them on the schematic, and connect them properly. We will also learn how to configure a circuit and prepare it for simulation. After learning the basics, we will start the basic electrical and electronic circuits. We will design and simulate circuits based on concepts such as Ohm's law, Kirchhoff's law, series and parallel circuits, voltage and current measurements, and basic network analysis. After that, we will move towards electronic circuits, including diode circuits, rectifiers, transistor circuits, amplifiers, and other fundamental circuits. We will then explore op-amp based circuits, filters, waveform generator circuits, and other analog electronic systems. After completing the analog section, we will move towards the digital electronics. In digital section, we will design and simulate logic gates, Boolean logic circuits, multiplexers, decoders, flip-flops, counters, registers, and other digital systems. Later, we will explore microcontroller-based circuits and embedded system projects using Proteus. Therefore, by the end of this course, our objective will not simply to be learn how to use Proteus software. Now, our main objective will be to develop the ability to design, simulate, test, analyze, and troubleshoot complete electronic systems using Proteus. Now, let us think a note for the course learners. What steps the learner should follow while learning this course? This course is designed in a step-by-step manner, starting from basic concept and gradually moving towards more advanced electronic systems. Even if you have never used Proteus software before, you should be able to follow the course from the beginning. While designing each circuit, we will not simply create the circuit diagram, we will also understand how the circuit works, how to run its simulation, how to observe the output, and how to interpret the simulation results. I strongly recommend you do not simply watch the demonstration, try to build each circuit yourself in Proteus. Change different component values, modify the circuit parameters, run the simulation again, and observe the changes in the output. This hands-on approach will help you to develop a much better understanding of electronic circuit design and system behavior. So, Without any further delay, let's begin our journey into the electronic system design using Proteus. First, we will understand the Proteus interface, its basic tools, and overall working environment. So, see you in the next lecture.